So welcome into the Future Ready podcast. My name is Conor Peick. I'll be moderating our discussion today. And I'm joined by Matthias Loskyll and Samir Desai. There are two excellent AI experts from Siemens here. So really excited to jump into a discussion today. So to get us started, I would love both your guys' perspective. Maybe Matthias, you can start for us. Basically, why industrial AI and why now? Why are companies really looking at adopting these solutions? What problems are they facing? What are they looking at industrial AI to help them solve?
So if you look at industrial companies today and where they are, it's like a perfect storm, you know. They still have the requirements they've been facing for decades. It's about high quality of their products. It's about efficiency and cost saving in production. But in addition, now they are facing a lack of skilled labor as a big challenge. So in the end, labor shortage, workforce shortage. But also they have to get their production more resilient because of all the supply chain crisis going on, like on a regular basis in the meantime. And they really have to get more adaptive in their production to unforeseen situations, to additional product variants that they have produced. So it's really these old challenges, known challenges, but also the new ones coming up. So it's really the time to act for industrial companies now to use AI to really get to the next level of productivity.
And so, Matthias, you bring sort of an automation perspective to this. And Samir, from your side, it's more of the engineering perspective. So what do you think from an engineering perspective? Maybe some of the same challenges that Matthias just outlined, or?
Yeah, we kind of see some of the same and with a different flavor on it, right? So like, let's pick the demographic issue. We're seeing a lot of change in the type of users that our customers have. We're having the older generation move out, the newer generation coming in, and the newer generation is very impatient, right? And for them, they want to really quickly learn the tools and do their tasks. So how do you really bring these new users on board? Some of those are the challenges they're running into. They got data today that is completely fragmented in lots of different systems of records, if you would. And when they're building their products, this data from different systems need to come together. So they're kind of seeing that. And the last part that we see is hyper competitiveness. Their competition, new, not just local, but global competition is moving really, really fast. And they're saying, how can we cut short our development times, our engineering time, so that we can take our products much more faster, right? So all these things are coming back together, a perfect storm for our customers, right? And that's where they want to be able to use AI.
Yeah, that perfect storm. So maybe some of that innovation cycle speeding up, I mean, perhaps similar in the automation world as well. So maybe as we can jump into a bit of an AI introduction here for some of the listeners who maybe are not quite as familiar with the technology as you guys. Maybe really quickly, Samir, you could give us a rundown on consumer versus industrial AI, some of the different requirements, the different needs.
Yeah, sure. So, when we say consumer AI, go back December 2022, ChatGPT, right? Kids to their grandparents, everybody's using it. But what are they using it for? It's primarily around text, videos, images, things like that, right? Which is ubiquitous all around the place. We were using Google and YouTube for that. Now we're using AI for all those things. But when we look at industrial side, what our customers do, yes, they have documents and they have images and they have videos, but that's not their primary type of data. They're dealing with engineering, design engineering, manufacturing, simulation, manufacturing operations. That is a very complex type of data that has to be dealt with, right? And so is where the big difference comes in. And we don't see in the consumer marketplace what are known as those modalities for this complex engineering data available. So that separates us, and which is where we start getting into our strategic elements around industrial foundation model. It's all about building models that deal with the engineering, the manufacturing, the operational data that can then be used to build AI features on top of that, right? So that's kind of like the real big difference in terms of what is the type of data that our customers use for their products.
Right, I see. And presumably there's also a question of risk involved as well. I mean, in the production environment, something, an AI doing something that you're not expecting or not ready for could be potentially extremely costly or damaging to a production facility, presumably.
Yeah, actually, besides the topics that Samir mentioned, so the different data modalities, we need models understanding the language of engineers, so to say, or the language of the industry. That's an important aspect. But besides that, just think about where AI acts in industry. It doesn't act in the digital world only. It also acts in the real world. We're actually operating factories using AI. And if you think about this, this means there can be safety issues because of wrong predictions of an AI model. There can be massive downtimes or standstills of a production line, which can cause a damage of millions and millions of dollars. Yeah. So it's a different thing than I always try to explain to my family what I'm actually working on. So I always say, just think about recommendation of your favorite movie or using AI to translate some text. If something goes wrong, it's not a big damage. If something goes wrong in the industrial space, we have a huge issue. So it's all about reliability. It's about deterministic systems that engineers are used to. And how do they then interact with an AI system, which is by definition non-deterministic? So how do you really integrate that into a reliable, trustworthy manner that can be used for industrial production use cases?
If I could just add one thing
Please.
on top of what Matthias just said, there's this key difference of language of the internet versus language of engineering and manufacturing, right? And that's where the main separation happens on the consumer versus industrial AI, the risk elements. Engineering and manufacturing is a science.
Yeah.
It needs to be deterministic. If something goes wrong, then the car or the plane or the machinery that our customers are manufacturing, there's going to be a huge problem there, and we cannot risk it.
Mm-hmm.
That's the...
I mean, certainly. And Matthias, you mentioned this aspect of it, that AI is, in some ways, is inherently non-deterministic. So it's a fascinating way of thinking about how do you build it into systems in a way that that manage that risk, I suppose, for you. It's a really interesting marrying of this technology that can maybe be very powerful and predictive and help you maybe knit together patterns you couldn't see otherwise, but doing so in a way that you're not going to open yourself up to too much danger of a wrong prediction or something like you mentioned.
And this really depends on the use case, how critical it is. Sometimes it's okay to have a certain non-determinism and work on statistics and predictions of an AI model and work with that. That's fine for many use cases, but there are some that are really, they go into the actual control of a machine or of a production line or even AI-based safety applications. That's also what we see coming up more and more. So then we really talk about an embedding into, I would say, something like a sandbox or into some guardrails that are more rule-based maybe even, or that at least can be certified to a certain level, and you can make sure that the outcome of the AI model is more predictable and more deterministic to really be able to use it in such critical environments as well. It's similar to autonomous driving, actually.
Okay.
We have similar challenges there in industrial production as well.
Yeah. I've been thinking of that safety criticality and making sure that the system doesn't step out of its bounds or something to that effect. Yeah. So maybe as we kind of keep thinking about this AI introduction in a way, there's obviously lots of different AI models, maybe different AI applications that can be used in engineering and production environments. Things like maybe people will have heard of predictive, generative, agentic, physical AI, all these different terms, right? Maybe you could give me just Samir, maybe a quick rundown of, are there different benefits, maybe different advantages of these various models or systems? How do they inform perhaps a engineering process differently?
Yeah, fair question. So I mean, AI, first of all, has is not new, right? Generative AI is new. Predictive AI has been there for 3 to 4 decades, right? And if you look at in the Siemens portfolio, we have been doing predictive AI for a long time. Now, there is an increasing value going from predictive to generative to agentic, right? Predictive, as the name is suggesting, is it'll say, hey, this is what could happen and this is in there. But generative is saying, well, it's not only we are predicting it, we'll help you create that. We'll help you generate that information for you. That takes it up to the next level. And then beyond that, the agents are coming in with agentic AI and saying, we will assist the engineer in creating that, right? So now the engineer is free to do their primary task, which is doing engineering and design engineering and manufacturing engineering, and it's taken away repetitive actions and tasks that they have to do. So there's always an increasing level of benefit that they get out of it. Now, we use this in different ways on the engineering side of our software portfolio. All of the above elements are used in a way that when a design engineer is going into our mechanical or electrical design software, we got co-pilots in there that they can quickly start chatting with them and say, hey, I want to do ABC. How do I do this thing? I want to create an electrical diagram. I want to create a 3D geometry with so and so. How do I do it? But not only how do I do it, can you go create it, do it for me, that I'm going to review and say yay or nay, or I'm going to edit it in there, right? So we kind of start doing that across our portfolio. There's several examples of how we take advantage of all these pieces for us.
Fascinating.
I think there's one thing which is really important. It's not always about following the hype, and not everything should now be agentic or generative. We see a lot of use cases actually out there in industry where predictive AI works best, because these are specialized models solving specialized use cases. So that's a perfect fit. And there's no need actually to go for the hype topics. But that's something that where we really also have to consult our customers sometimes to clearly say, okay, for this problem, you don't even need AI. For another problem, you could use predictive AI, which will work perfectly fine. You just have to train it based on certain data to make predictions then. And for others, there's really the need for generative and agentic AI approaches.
That's a really good point. Matching the tool to the problem that you have, right? And it's right tool for the right problem at the right time. And you don't just sort of throw the AI blanket over every problem that you have and expect that it's gonna work out.
Yeah, and you brought up a very good point, Conor. There, the right tool, right?
Yeah,
and that is something that we call as part of our 3-prong strategy. One of the prongs is what we call engineering AI or in-app AI, which is the users are using the software products for years. Each one of these products is designed to do something special, right? And as the users are performing their task in that particular tool, in the particular context of everything that is around it, including the data, that is where we interject AI and say, we understand what you are working on. Do you have a 3D geometry, or you have a simulation, or you have a change, or you have a manufacturing process plan that you're working on? Our tools understand that. And then we bring in AI to assist the user in doing the next step better, in predicting the next step that they have to perform, in predicting how the geometry is going to evolve, how the change needs to happen. So it's really bringing the AI to the user rather than telling the user, you go do over here and go figure out how you're going to do AI, right? So that's a big thing that we do.
Yeah. So then thinking about, it's a really, I think that's an excellent kind of look into how the AI is influencing the engineering process, right? From, moving from design through to, as we're approaching more automated production as well, AI managing the factory floor perhaps a bit more. So Matthias, how do you think, or how do you see, perhaps is a better question, how do you see companies actually deploying AI on factory floors? What sorts of systems are they putting in place to automate their production a bit more?
Yeah, actually systems based on all the different areas that we touched on. So a lot of predictive AI, but also generative and agentic AI approaches. The first one's even agentic workflows now. and very different areas of applications. So very famous and popular one in industries is obviously visual quality inspection. So using machine vision applications in industries to solve the problem of inspecting products or intermediate products if there are defects, simply speaking. So usually you have a camera and some products running over a conveyor belt, for example, and you want to automatically inspect those. That's still a manual task in many applications today. So you have human operators standing there all day long, inspecting the products on the conveyor belt and picking the ones that are not okay, so to say. And that's what we can clearly automate to a large extent today with AI technologies. And we do that with different products actually that we have. We have like Inspector, which is an out-of-the-box quality inspection system for detection of defects, surface defects, for example, or detection of foreign objects or missing objects. So the more simple use cases works fine for metals, electronics, plastics, for example. And there are extremely complex quality inspection use cases in consumer packaged goods or food and beverage, for example, where you have thousands of pieces running over the conveyor extremely fast, and you still want to inspect those. And there we have another product which is called Visual Inspection Cockpit. So this is we call it closed loop AI. So it inspects the product, it detects a defect, and it sends a signal to our PLCs. So the control of the machine or the plant, and then this one gives a trigger to reject the products automatically. And all of this in real time, so to say. And this is really cool. This is highly embedded into the production line. So quality inspection, besides that, predictive maintenance, obviously. So forecasting if there is a defect of a machine, if a breakdown could happen soon. Actually avoiding that breakdown, sending a maintenance engineer in time. That's predictive maintenance, where we have Desai as our product. And if you look at process industries, like chemical production, for example, we have advanced process control. So this really goes down into the parameter optimization of your control program, tuning the parameters on the fly based on the values of the process. So this is also deeply embedded into the production process itself. We call it actually physical AI if we have this close integration into the industrial environment. If we actually act also, we do not only perceive and reason, but we also take action automatically or autonomously. This is what we call physical AI, maybe to add another category to predictive, generative, agentic.
Yeah.
There is also physical AI, not only connected to autonomous robots and those aspects, but also tightly embedded into the control system of a production line. And actually, I would say all of this is industrial AI, how we understand it. It doesn't matter which flavor of AI it is, all of this is under the bracket of industrial AI.
Awesome. And, one thing that obviously we love to talk about technology and all the exciting things that we might be able to do with it. I think one of the practical realities maybe for customers is the thought of adopting a new tool and, maybe they already have other tools in place. And what they don't want to do, presumably, is totally replace their entire ecosystem. So how can we work with what customers already have in place and build on top of that?
So wonderful question, because we are already doing this with our customers, right? So I can do 2 or 3 different variety of examples, but we'll give you the value of how customers are thinking about this and how we are partnering with our customers for this. So if you take an example of our PLM system, Teamcenter, that's the number 1 PLM system in the world today. We have a customer who's been using it for over 10 years, right? And then we added certain elements of AI in there, and they said, we would like to try this thing out. So what did we do? We provided this capability to them in the Teamcenter product, but we partnered, we ran a set of proof of concepts with them. They say, Mr. Customer, what are your top 3 use cases? Let us run through those with you, not handed over to you, but with you, and show to you how this is going to add value and bring more importance to your end users. And they loved it. And at the end of it, they bought 2,500 seats of that software offering from us, right? So that's one. The other example is look at a completely different industry, chip design. Mm-hmm. ARM, which is a chip design company, they have to work under Six Sigma quality, which means that when they design chips and when they go to manufacturing, the manufacturers, only 1 in a billion chips can fail. 1 in a billion, Six Sigma. To achieve that, they have to run a lot of simulations, and they were running about 5 billion simulations over a period of months.
Okay.
What we did is with one of our IC chip design verification software, Solido, we introduced a generative or a predictive model in there. And they started using this predictive model. And instead of having to do 5 billion simulations, they're down to 2,000.
Oh my goodness.
That's a magnitude of 2,500x. Actually more than that.
Yeah.
So right, it's 2.5 million x improvement that they've gotten out of it. And instead of months, they are able to do that in hours. So these are like some very real examples of what we have done with our customers. The last one with PepsiCo, industrial metaverse. We partnered with PepsiCo as well as NVIDIA, where we are using NVIDIA GPUs to do what we call as digital twin composer. And we built this together with PepsiCo. So what do you want to do? What is your scenario? What's your factory layout? How are we going to do this visualization? And we're with you for that. At the end of the project, they have it deployed. They're down here today. And they have achieved up to 15% reduction in their capital expenditure. So real AI offerings with partners, keeping it real, avoiding the hype, and bringing it to them. So that's how we work and take AI and with our customers and with our partners.
Work with the systems they already have in place.
Yes, yeah.
In the production environment as well, I mean, you have, I'm sure, a large mix of brownfield facilities where customers have machines of all ages, I imagine. So yeah, a similar question, I suppose. How do you navigate maybe integrating AI into these facilities where you might have machines that are, I don't know, maybe older than me in some cases?
Actually, in a very similar manner, but with different technologies, obviously.
Okay.
So it's all about data connectivity in the first place. So you really need to get the data out of these systems. And as you said, it's usually a legacy system that is their brownfield applications with mixed vendors, with different generations of controls, for example, or of drives. And we have to get the connectivity right in the first place. So that's the homework that every customer has to do then. And we also help the customers on this journey and with some software components that we can offer to make connectivity easy, to get the data out of the systems and then send this data to usually a centralized environment, like based on our Industrial Edge platform, we can contextualize this data, even sending it to our Altec Graph Studio. We will expand on this later, I hope. So I'm talking about the data fabric. That's really key to bringing all these data items together, getting it to a certain semantic level, contextualizing the data, and then you can put the AI applications on top. So this is also a journey for customers to transform their operations into an AI-ready system to really leverage these applications. And we also recommend to go for the high-value use cases first, to start with some pilots, to get the breakthrough with those, but from the beginning, standardizing the infrastructure. So not reinventing the connectivity layer with every AI use case, not reinventing the AI runtime, so the execution, the inferencing of the AI models with every use case. We saw that very often actually happening. So we highly recommend to standardize all this on a joint software-based infrastructure. And then you can go and roll out these applications and put further AI use cases on top of it.
You know, and you brought up the idea of the data fabric, and I think let's jump into that right away, because I'm very interested in the idea of how do you connect all these different maybe silos of data that exist within most companies, and both how it seems like to leverage AI, you need to do that connection, but perhaps AI can also help in creating that data fabric and building those connections as well. Samir, I don't know if you want to start.
Yeah, I can start, and Matthias, please add on top of that, because we both are focusing on that for for the key elements of engineering as well as automation, right? And so what we typically have seen over, again, 2 to 3 decades that our customers have been using, and this is a problem of what the customers call as either data silos or dark data. What do they mean by that?
Yeah.
Right. So let's take an example that one of our biggest industry is car manufacturers, right? They're doing their design. They have their design information in our PLM system, Team Center. But when they look at their vendor and sourcing information, that's sitting in ERP. They have their customer relationship data in CRM. And then they have a lot of homegrown systems implementations as well. Now, when they're building this car, it's not just the design or the sourcing or the in-house data that is by itself important. The connection of this data is more important, because when they're saying, hey, I'm going to make this change in my design data, it is going to have an impact on sourcing. It is going to have an impact on manufacturing, which is where Matthias and the team comes in terms of automation. It's going to have impact on a multitude of other things. And how do you understand the impact? Traditionally, you would have to get people from these different disciplines, the subject matter experts. They're going to come together. They're going to look into their systems. They're going to try to figure out. And it's a long cycle. Takes days, weeks, months sometimes, right? Wouldn't it be cool to really provide an automation of this that it understands the relationship of all this data, and based on that understanding, you can run AI on top of it, but you can run analytics on top of it, and you can perform actions on top of it, right? This is where making it smarter becomes critical. This is what customers mean by dark data. It's like, I know I have all this information. I know it's somehow connected, but I don't know what the connection is and how. So we're solving that through what we call AI Fabric. Right. And the primary fundamental offering there for us is based on our RapidMiner portfolio. RapidMiner Graph Studio specifically is what we are using. It's a great piece of technology that we have, part of our Altair acquisition that we did just over a year ago. And what we are doing there is this concept. I'm going to get a little bit technical here, but is the concept of ontologies, or semantic relationship of information that is in these different places, right? So we are bringing Siemens, because of its domain expertise that we have in all these domain areas, because of how we understand the data works and it connects, because of how we know data is secure, and security is more important to our customers than anything else today, right? We bring all of these pieces together into this ontological view that says, here's how your design information is connected to your supplier information, to your manufacturing information, and now you can start asking questions. Not only ask questions, but you can build agents off of that ontological representation using either our Mendix low-code tool or the RapidMiner tool. You can run analytics on top of it. And once you figured out what the connections are, now you can say, hey, this piece of information in one system is changing. I need to effect a change in another system. You can orchestrate that because of the way of how we've established this whole ontology, right? It's a very, very powerful offering. It starts, and that's why when we look, it's not just engineering. It's in the manufacturing world. It's in the shop floor world too. And Matthias, if you want to talk about how you're looking at this thing in your domain.
Yeah, so I have a very similar view. So this proper data foundation is really key to scale AI in industries, right? And also from an operations or running the factory perspective, it's the same thing. You still have to integrate the data across different data silos that are still there very often. And it's also like you can also give a feedback loop to the design and the planning phase of the production, actually. So just imagine the example that I mentioned before, the quality inspection. So you detect a failure or a problem of the product, and now this occurs over and over again. This usually means there's something wrong in the process of the manufacturing plant before this quality inspection step. So something is deteriorating or some process parameter is drifting. So usually this means you have to optimize something, and you have to give feedback to the design and the simulation and the planning part of the whole production line. So closing this loop across the whole value chain, this is where really data fabric is needed. And I think it's a great tooling that we have in the meantime here. So I was always dreaming about this, doing my PhD in the field of knowledge graphs, actually. And so this is the underlying technology that we use here. So breaking up data silos, having a joint ontology, how we call that. So it's a joint terminology to have the different items on a semantic level. That's the right step to really break up data silos. And this is needed then for agentic workflows that operate across the different phases of industrial production.
And so maybe part of building that foundation, it seems to me that the data fabric in some ways is like providing a really solid base level for AI to operate from and for you to build more valuable applications maybe on top of. It seems like part of that has to be also developing trust with customers and developing, trust in a perception of reliability with your users, perhaps internally and externally, either way. So, yeah, how do we go about building that trust to set a strong foundation for companies as they're adopting industrial AI?
Yeah. On multiple cylinders.
Yeah. Okay.
We have to fire on multiple cylinders on that, right? And what I mean by that is the fact that, number one, transparency. Transparency to our customers about how we are doing AI, what technology are we using, making them aware of that. So as customers understand that, they'll feel much more better. Not will, they do, because we're already doing this. I've already gave you 3-4 different examples earlier, right? So that's one thing that we do. The second piece is we do use partner technologies. We use open source technologies and other partners like NVIDIA, or we actually use standard off-the-shelf LLMs as well, right? So we make that, as we bring those technologies on, Siemens has its way of how we monitor the compliance of these partner technologies to what we hold ourselves accountable to. That way, the customers get better understanding. They say, okay, you guys are. Okay. The third element is about data. Customers have their data, which is proprietary to them. It's trade IP for them. And number one, we never use a customer data to train our models or to bring it within Siemens unless there's an explicit agreement and a permission with the customer. They say, yes, you can do it. Even simple things as a user typed in a question in the chat in our cloud-hosted deployment. We don't even capture that. We don't take that as Siemens, right? Because that's customer data. So simple things like that, we don't do any one of those things. And there are lots of times customers say, hey, I have standardized on my own LLM or my own deployments. Can you use that? Absolutely, yes. We're very open. It's an openness strategy that we've followed for 30 plus years. It started with API openness and things, but with AI, it's very different. Customers can do their own LLMs. They can bring their own LLMs. They can plug it in. They can take our LLMs, train off of their data in their environment. They can take our piece of software, deploy it in their environment, whether it is on-prem or whether it is in their cloud environment. So we do everything, and we are very open to the customer about how we are doing things and what it means to them from a security perspective.
So Conor, I could give it another flavor, different flavor. So it's also about stepwise introduction of AI into the existing tooling of our customers. I think that's really key, because it's also about, so trust is also about the acceptance of the actual users,
right,
of the AI-based software.
Yeah.
So think about an engineer sitting in front of TIA Portal, which is our automation engineering tool. So this is where you write the code for the PLCs that then actually run the factories. So those kind of engineers, they want to understand what's going on here and what recommendations does the AI give. and why are these recommendations given, or even if you think about agentic, it's even code generation autonomously. So they really want to understand what's going on behind the scenes. So AI being a black box model in many cases is a challenge for engineers by definition. So it's about the stepwise introduction. First, AI as an assistant. The human is clearly in the lead of engineering, of creating a program or creating the design, creating the simulation. So that's why we embedded AI capabilities, generative AI capabilities into almost all our tools in the meantime. I would say those are existing tools that the engineers and designers know and worked with for decades. And now they have an assistant by their hand. And they know that also from their private life. They're using ChatGPT or Gemini and the like. So that's not so a big hurdle then anymore, because they're used to using a chatbot as a support, as an assistant already. And then the next step is adding agentic capabilities. And we've just announced here on Hannover Fair, actually, the Eigen engineering agent, which is embedded into TIA Portal. So the well-known automation engineering tool. But it takes already over repetitive and tedious task of an automation engineer. It can help generating code. It can help generating the documentation of the code. It can also help with troubleshooting if the program does not work as expected. You know, this is really the next step then, already automating parts of the workflows, but still the human is in the driver's seat and making the final decision and giving the final go.
It's about having the technology, in some ways it's allowing it to prove its reliability and its value before you sort of set it loose.
Yes, and like what, similar to what Matthias said, when with some of the things that we started offering, our initial co-pilots were in terms of assisting the user in how do I do X, how do I do Y, how do I do ABC, right? And what we call as basic simple doc assistances. And then they started telling, okay, I see what you are doing. You are giving me the right answers, which is what I was doing. And I'm learning more because you're giving me some additional ideas and steps how to perform what I need to do. So it builds up their confidence level at that initial step. And then we started introducing more and more features and capabilities at a higher advanced level to them. And they quickly started adopting. I mentioned about this customer buying 2,500 seats of one of our Copilot offerings in there, right? And so that's by building that trust and relationship with them.
This is, I think it kind of brings up, Matthias, earlier, you mentioned the idea of starting with a very specific use case and, demonstrating success with a pilot and then scaling from there. And I mean, I think it makes a lot of sense. What I would love to know about is, as you've maybe interacted with customers who have tried to implement some of these tools, where do they maybe get tripped up in that process of scaling up through the stages that you kind of just outlined for us? What maybe gets in their way that disrupts that process of scaling?
Yeah, that's actually one of the biggest challenges in scaling AI in industry still. So if you have a look at the recent reports of different analysts, they always state similar numbers, like 80 to 90% of AI projects don't make it from pilot to actual rollout and scaling. Okay. And I mean, that's a massive issue because the return on invest actually will come if you scale AI in the sense of rolling it out from one machine or one production line to your global factories. That's what you want to do. You don't want to solve one specific use case for one machine. You really want to deploy it across your worldwide factories and leverage the potential of AI to optimize your production. And the two key challenges actually. One we addressed already, which is the basic the data foundation, which is the homework that customers have to do, really get the connectivity and the contextualization of data. And the second big issue that we always saw, at least in many factories, we saw similar approaches where data science teams started to reinvent the full software stack from scratch. So they started to implement AI runtimes based on open source. They started to built inferencing agents on their own, started to deploy the AI models on specific hardware. So we strongly believe that it's important to have a common infrastructure software layer to run AI models close to machines, because we still see many use cases where AI must be deployed on the shop floor, close to the actual physics, and not be running in the cloud. There are use cases where it's okay to run AI models in the cloud, but we still, for our business at least, we're always close to the automation and to the shop floor, because it's really embedded into the real-time environment. So, and for those, that's why we also developed a software portfolio for this. So it's called Industrial AI Suite. It helps customers to standardize on an AI infrastructure for deploying, managing, and running AI models on the shop floor. This is also where we work with NVIDIA. If you need GPU acceleration close to the machine within our industrial PCs. So this is also for high-speed inferencing on the shop floor of AI models. And for example, we helped our customer Audi to deploy and to scale their use case. This was about spot welding inspection. Mm-hmm. And if you think about automotive, this is an industry which has been optimized over decades to an extreme. But still, with this solving this use case and then scaling it to different factories, this is a massive improvement, a massive optimization that we're still able to implement using AI technologies here.
I think I love what you said about as well. It's not about solving one problem in one facility. You want to try and take that and scale it across, for these large companies, across your whole global portfolio of facilities, and that's where you really create that business value, is as you scale it across your entire ecosystem, really. Maybe the other thing that maybe gets overlooked sometimes, I suppose, in trying to scale up these programs, is the idea of how do you bring your people along in the transition. So I think we've kind of touched a little bit on how we think AI will change the work of an engineer, how it might change the work of someone on the shop floor, perhaps. And if you guys have more to say about that, of course, would love to hear it. I'm just curious, how do you think companies can really focus on bringing people along on that transition? How can they make sure that their people are ready to adopt a new tool? Because if they're not ready for it, if they're not ready to use it, then it limits your ability to deliver value. Anyway, Samir, what do you think?
Yeah, so I think the way that we are doing this is by not introducing new tools to them. Okay. We're introducing new features to them. It's a huge difference.
Yes.
Because they're already using a set of their favorite tools, which we as Siemens provides them, right? And then we're saying, you are performing this one action. Here we have an additional feature for you that will make it easier and faster for you, right? This feature is going to assist you in doing your task better and faster, right? So we bring in our AI, whether it is just the predictive part or our agents or our co-pilots, that these are actually here to assist you in performing your task. And oh, by the way, the AI is not going to make the final changes to your data. You will be in control of the final action. This is what we call as human in the loop, which is largely present as part of the agents that we offer. But generally, co-pilots and agents, they have this notion that you ask a question, comes with an answer, or it suggests that this is what I can do for you, right. What I can do for you, yeah. Not I will do for you, right?
Or have already done.
Or I have already done, right? And then the tool then asks the user, I can do this for you. Would you like me to do this? And then the user they can choose to say, yes, please do it. After they do it, they won't actually commit all the changes, right? They'll say, here's what I've done. This is what it looks like now that I have done what you asked me to. Would you like me to go ahead and save this change that I have made, right? And at that point of time, again, the user is in complete control throughout this process, right? So they don't feel alienated because of what AI is doing, but get this experience of being assisted. They're being experience of their task being accelerated to do that. That's how we are actually engaging. We kind of meet with customers almost every day because their IT departments are trying to figure this thing out, how to roll this in to their users. Because what's happening in our customer base is the business users are saying, hey, there's all this AI hype going on out there. What are you doing to help my users with AI? And the IT teams are coming in and saying, Siemens, can you tell us what you're doing and how we can do this? So we start engaging now jointly, not just with IT, but IT and business, because the business users are concerned, but the IT users are concerned too. So that's kind of how we're kind of doing this in partnership and kind of slowly introducing this and showing the value to the end user. Like, you're not being replaced. We're helping you to be more efficient, more productive. Because guess what? When we're doing this, you are able to spend more time on what you are actually supposed to be doing. Right. That's how we approach this.
So I think this statement is really key, Samir. So it's AI augmenting people. It's not replacing people. That's really a big misconception, misunderstanding. And that's also why people in the factories, for example, they perceive AI as a threat. They really believe this might replace their job, and I don't see that coming. If you think about how robotics was introduced years ago into factories, it clearly shows it's not taking away the jobs of people. But in the end, also, if you have a look at our own factory in Erlangen, for example, we deployed hundreds of robots in the last years, but the number of people working in the factory is still the same. So this means they will get freed up from tedious, repetitive tasks. They will have more freedom to be innovative and work on problem solving and optimizing the production, for example. And that's the way to go. And still, AI will augment them in their daily work, as it augments us in our personal life already, getting more productive every day, using co-pilots or using even agents to automate certain workflows. So this is the way to go, and that's really important. But that's why it's also a cultural transition in companies to really take the workforce with them on this journey. It's also about educating people. It's about training them and making them future ready for this AI-driven future, because there's no way out. This will happen anyway, with or without you. You know.
So maybe thinking a little bit into the future as well. I know there's agents are starting to become available. I know Matthias, you mentioned that we just announced the Eigen agent. And I think we've covered a little bit the role of agents, how they're a little different than co-pilots, a little bit more autonomous, still with that human in the loop in control of the process. What do you guys think is maybe the next big step in the world of agents, where we move from where we're at today to, let's say, 3 years down the road, I suppose, just to give it a time frame?
So, if you looked at towards the end of 2025, basically they say, hey, 2026 is going to be the year of the agents. It truly is the year of the agents. Mm-hmm. We talked about the Eigen agent that was released. We see a lot of agents in the industry out there. With respect to software, we're going to have over a dozen plus agents that we're going to start seeing coming out in the next few months here that our customers are going to be able to use, right? That at the agent levels, also there's going to be kind of two broad categories of agents, if you would. One is this agents, which what we call as domain agents, right? Which are the agents that are sitting in the specific tools that the users are using. They are capable of doing certain things specific in that tool with the human in the loop, all that wonderful stuff. Then there is a higher level agent, which typically in the industry is known as orchestration agent. Okay. For us, the way we approach that is what digital thread agents, right? What do we mean by that? So we've had different tools in the pipeline, in the system, and there are digital threads that go from mechanical to electrical to simulation to data to manufacturing, right? There's different actions and tasks that are happening in the different systems. If you were to make a change in one place, going back to what we were talking about in the fabric concept, but agents come in here pretty active as well. Let's say I had to make a change to a certain part in a car, for example. Now that change is not just in one system. You have to make a 3D change. You have to make a data change. You have to, once you make those, you have to simulate that change. You have to update your manufacturing process planning. All these are happening in different systems, right? How do you thread all these actions in these different systems? That's where the digital thread agents come in. They orchestrate this whole activity that needs to happen, right? So clearly agents are going to be pervasive. We see them in these two levels within the systems, and then doing the overall digital thread orchestration as well. So I think that's going to be the big part that we see here. We talked about well, before I go there, one of the pieces is it's not just our systems. Customers are going to build agents outside of the Siemens systems as well. They're going to build agents on their ERPs, CRMs, everything. And our agents and their agents need to talk to each other for enabling this overall process. How do we do that? Something that we've not talked about so far is the concept of MCPs.
Okay.
Right?
Tell me about that.
So Model Context Protocol.
Okay.
That's what MCP stands for. Great. And it's all about how do you expose a set of services or APIs of a particular system in the agentic world.
I see.
Okay, so it's an interface for the agents to talk to a particular system. It's also a way our agents can talk to each other through the MCP protocol. What this means is that every system needs to expose an MCP server. That's a very techie term, but that's what it is out there today in the industry. And at Siemens, we're going to have a boatload of MCP servers. Every system is going to have an MCP server, at least one, if not multiple, right? And these agents from internal versus external are going to be able to talk through each other through the MCP servers, establish the orchestration. So that's kind of where over the next 2-3 years, the big activity is going to happen, in addition to the fabric conversation we had earlier already. So we won't kind of go back into that thing,
Sure.
but fabric and agents are going to be the two big things that are going to happen.
Yeah.
I actually see in the production phase of the factory very similar patterns coming up. So you will also have domain agents, so to say, to solve specific tasks, but then there will be orchestration agents connecting those and making sure you can solve the whole workflow. Just think about spotting a problem in your production line. This might be one agent, like monitoring it. There might be another one analyzing the root cause. So what could be the reason for this problem in the production line? And then there might be another agent starting corrective actions, optimizing parameters in the process happening before the breakdown, for example. And then another agent feeding back this information to a design agent or planning agent, right? So this will be a connection, and it will be also a challenge for us to give those agent guardrails, because we give away certain control in this very critical environment. So how do we design that? How do we make sure these agents speak the language of our domain? How do we make sure they work on something like an industrial foundation model, having the right data sources below? So this will be the big challenge. And besides that, I see one additional breakthrough coming in that area, which might be physical or embodied agents. So you can think about agents being software workflows, but you can think about agents sitting within a robot, for example, making the robot more intelligent, perceiving the environment, reasoning about what's going on around me, and then taking action. And for example, we work with vision language action models in this case to make robots more intelligent, to handle tasks that can't be automated today, like handling of very dexterous items or textiles or cables or things where you can't really program the robot because the situation will always be a bit different. So this is another step which I also see in the space of physical AI, where we get the next big thing in automation, so to say, automating the unknown, how we sometimes call it. This is the next big lever coming in hopefully the next few years.
Yeah. And maybe just to bring it back to that, what we talked about earlier with keeping people not necessarily in the loop in this case, but with agents where we're talking about building these more autonomous systems. They're obviously not fully autonomous, but as you talk about these agents being able to take these actions on their own, reason and perceive the environment, as you were just talking about with this physical AI, the embodied AI, and perhaps a robot. How do you guys think that will change the day-to-day work for an engineer or someone on the shop floor or a production engineer, for example? How do you think they'll interact with these agents to work in this new world of more autonomous systems?
Human in the loop.
Okay. Yeah.
That's the way how they will interact with the agents, right? Because we're going to provide all the benefits of the agents to help automate and assist the users, but the users will be in control. That's where the human in the loop is the biggest thing in there, because our customers build mission critical products and we don't want an AI to make a decision for them, at least not yet. And humans are important. There's decades of knowledge that they have that needs to get in there.
Comes back to augmenting the human, not replacing them.
Exactly. AI and humans working together. This we will see. And even if you talk about AI-powered autonomous production, very often we're not talking about dark factories. So I'm deeply convinced there will be humans needed for many tasks, both in the engineering phase, but also operating and running the factories. This will be an interplay between robots, autonomous systems, agents, and humans in the end.
So, to wrap up our conversation today, guys, I would love to take a look again into the future, looking ahead at the next decade. And we talked about agents and some of the next advancements and steps you guys see that might come in that realm. But maybe broadening our perspective a little bit. If you were to bet, let's say, if you had to, maybe not necessarily place money, but if you were to I don't know, stake a coffee, let's say, I don't know. If you had to bet on a breakthrough that might define industrial AI in the next decade, what do you think that breakthrough could be? Is that maybe it's something we've already talked about, but if you see something else perhaps coming down the road?
Honestly, we've talked about the topics on agents, the fabrics, the generative elements of it. I mean, those are the things that are going to keep on growing.
Yeah.
Having said that, this industry has been on a crazy trajectory. You don't know what you're going to see in the next 2 months that will become the next big thing, and that we'll have to go and adopt and work on it, right? So that's kind of what I think right now, Conor.
I agree. It's almost impossible to predict what will happen in the next decade.
Yeah.
So at least technology-wise, in the AI space, it's moving so fast, it's impossible. But on the other hand side, if you have a look at industry and the manufacturers and companies who are our customers, they will need time to adapt this technology. And this will happen step by step. They will go in the direction of AI-powered autonomous production. They will use agentic workflows. But this will happen step by step, and it will take a decade until we see that really in very broad application in industries. That's how this industry works. And that's by nature because of big investments they made already, because of critical production environments. There's only the way of step-by-step introduction.
Yeah. It's something that's become something of a theme, I think, is there's this idea of dream big, start small. You focus on the application, but you have big ambitions in the future. You just step by step, right? You work your way up the ladder, I suppose.
And you're so right on spot. The thing that I had in mind was, dream big, but start with practical use cases.
Yeah.
Right? Start with ones that are the low-hanging fruits, the one that you can immediately take advantage of. Build the confidence, like Matthias was saying earlier, build the confidence, right? And then start taking more and more things. But the most important part is be practical. Separate the practicality from the hype. There is a lot of hype, but you got to separate it, right?
Yeah.
And go in that way. So that is how I would think about it.
So if I would recommend something to the companies out there
please.
to tackle this difficult journey, it's really 3 steps in my opinion.
Okay.
First, get your data foundation right, as we discussed. Second, start with the high value use cases and then start rolling those out. And third, upskill your people. Don't forget your people. take them on your journey, think about this cultural transition that we are on, and look for a good partner, a strong partner who understands industries. And I think the Siemens is the best one here, well positioned to help our customers along this digital transformation journey.
Yeah, I would just double down on the last part. Work with Siemens. We are partners. We have done this with a lot of customers already.
Yeah.
And we can do it with a lot more customers and make them successful with adopting AI.
Perfect. Well, Samir and Matthias, thank you guys so much again for your time today. It's been really, really wonderful taking this deep dive into the world of, well, deep dive for me anyways. You mentioned earlier explaining it to your family. I was like, oh, that feels like me, what you're trying to explain it to me. But yeah, thank you guys again for your time today. It was really, really a great pleasure for me.
Oh, thank you. This was a pleasure. This was a very good experience.
Thank you so much. It was fun.